Hey, it's Norm from Tested. I'm here at the BattleBots shooting, and while there's a lot of awesome engineering going on in the pit with the builders, I think some of the cool stuff is actually behind the scenes. This is Mark Setrakian, one of the best animatronics designers in Hollywood, and you're actually working on some of the stuff behind the scenes for BattleBots, right?
Yeah, I brought a very special item to display the BattleBots trophy. It's called Axis. It's a kinetic sculpture.
It's amazing. The trophy itself is a giant nut. And I know it might not get that much screen time on TV, but Axis, what you've built for it, can you describe the motion?
Sure. Well, Axis is kind of like a hand. It's a 5-fingered sculptural robot. And it's like a walking machine that's on its back. And so we place the trophy on its fingertips, and it spins the nut in this very graceful way.
In designing Axis, it looks like you told me it wasn't your first version of this. You've built multiple versions before. When you're designing it, do you design upside down so it's actually a walking robot, a walking hand?
No, the initial idea for Axis was specifically a hand. So the first Axis, Axis 1 if you will, has a wrist, it has 4 fingers and a thumb. It's in a very hand-like shape, and it holds a globe of the Earth, and that's the whole statement of the piece. For this one, for Axis 2, I wanted to optimize its capacity for weight. So I made it a little more burly, it's a little thicker, the overhang of the hand is not so far, so that heavy weight hanging down on it is well supported.
And then keeping the item that it's holding up balanced, because it's a very graceful motion. One finger is moving at a time, it's turning. I can't even do that with my hand as a human. How do you keep it balanced?
Well, there is a camera in the palm of the hand that looks straight up at the bottom of the nut. So the disc has a tiny black dot on it, and the camera looks at that dot, so you put the plate on the hand, the little eye, the single eye, looks at that dot, and it walks towards the dot. If the dot's in the center, it just spins. But if it gets knocked off center, it'll walk towards the dot and pull it back on center again.
So, Mark, Axis keeps track of the object it's holding up. The optical stabilization allows it to spin. It's moving gracefully here, but how fast can it move?
Axis can actually spin that thing pretty fast. The camera looks at the dot on the bottom of the whatever it is you're spinning, and earlier today I had a piece of plywood that I was using for calibration, and I got that thing spinning at about, 5 RPM, which maybe a lot more than that. It's hard to estimate. But
there are trade-offs, right? How wide the stances, how many fingers you want to add on that thing, the weight, the point of contact, all these things are factoring into your design.
Yeah, that's exactly right. And actually the gate generator was originally written for a hexapod, but it was designed in such a way that I could adapt to any number of legs. So I adapted it down to 5 legs, and you have things like you can control the phase angle between the legs. So are there 4 legs in contact at one time and 1 leg is moving, like we see here? Or are there 3 legs in contact at one time and there are 2 legs in motion, which is also very good. Then there's things like I can change the spacing of the fingers. I can bring that contact ring down really small. I can move it around. I can make it go up and down. The next thing I want to do is to be able to have it hold a sphere and spin the sphere like this.
So smart and scalable. That's amazing. You're not just designing it for one purpose, one use. You're designing a platform that can be applied to different use cases.
Yeah, exactly. I'd like to make one big enough to drive a car onto and have it spin that.
You've done so much animatronics work. People, they probably don't, even though they don't know your name, they know your work from commercials, from movies. You're working at Spectral Motion now. In conceptualizing an animatronic design, what do you want to put into it so when people see it, they don't immediately think it's CG?
For me, it's always all about the movement and detail, attention to detail. So when I make an animatronic face, I really work hard to put a lot of anatomy into it so that when it moves, it is evocative of a living thing. And that's the thing that I've always strived for, is bringing a sense of life to mechanical things.
So you consider yourself maybe even like an animator in addition to just a roboticist?
In a way, yeah. I don't ever consider myself, I don't describe myself as an animator, but that's what I'm doing. I mean, if you think of the word animate, it's to make something that is inanimate, animate, and that's exactly what I do. But I do it mechanically.
Can you talk about some of the technologies you're using when you're building and designing your robots?
Sure. So I design, most of my mechanisms now are designed in Autodesk Inventor. So I use CAD software. When I started out, it was all graph paper and pencil, and it took, I remember it took a long time for me to learn how to make that transition from paper to CAD, and then eventually I was much faster with CAD, and now I'm very fast with CAD. So sometimes there'll be a scan, a 3D scan of something to begin with, but if there isn't that, I always start with a hand-drawn sketch, and I build upon that. And sometimes if I'm partway through with the CAD model, I'll print it out and I'll draw on top of it in pencil. I really like having that free-form opportunity to just doodle on something.
So Mark, that's design in software. What about the hardware? What fabrication technologies have enabled you to help prototype faster?
I have a couple of awesome tools that I use for physical fabrication. One of them is a CNC machine, which is a machine that cuts metal down to whatever you want. And the other thing is a 3D printer. I have, it's a big, generous, super awesome machine. It's a big Stratasys Fortis 400. It's got a 16-inch height, a 16 by 14 bed, and it is a wonderful resource to have to make just pretty much anything.
Now, in terms of 3D printers, there's FDM printers, SLA printers, SLS printers, different materials. They're going to be good for different things. For people who are prototyping parts, are you finding that even FDM is suitable for some needs?
I specifically chose FDM because, number one, it was the technology that I was already very familiar with. The other thing about FDM is that the parts are very robust. They're strong. They're physically strong. They have a good shelf life. The material has a good shelf life also. The machine itself is fairly low maintenance, which for me is good because I like to be able to just go in and turn it on, and then if I have to turn it off for a week, I don't have to worry about it.
Right.
And the parts, I can pull them out of the machine, and I can just bolt them right into a functioning mechanism and expect to have pretty good results.
Durable as well?
Yeah.
Oh, wow.
It's not as durable as, let's say, fiber reinforced nylon, but it's strong enough for a lot of things.
Are you finding that these new technologies allow you to just go crazy with your designs and things you're able to do today? Like, were there restrictions 5-10 years ago, that things you couldn't do then that you could do now?
That's definitely true. Some of that is just in the design process, which is the CAD software allows me to wrap my head around more complex designs than maybe it was possible before. The 3D printing obviously allows a lot of incredible things that were not possible before. One thing that you should keep in mind is that every process has its limitations and its advantages. Water jet cutting, a super simple technology. If you understand the limitations, you can make incredible stuff very cheaply with water jet cutting. The 3D printing, there are things that it's really not appropriate for. Yeah. But it also brings up a lot of opportunities as well. So the more familiar you become with the processes, the more productive you can be.
Access, obviously, really impressive, but you also have a ton of other projects. Are there any things that people might see out there right now that you want to talk about?
Sure. Well, okay, so the last project I worked on was an art project, actually, and a conceptual artist out of New York named Jordan Wolfson, a very successful New York conceptual artist, contacted me and Spectral Motion about building an animatronic art piece. He came to us and he described this thing, and I was like, well, that's impossible. Great, I'll do it. So we built, he and I and Spectral collaborated and built this figure. It's a female figure that dances in front of a mirror. And about 1.5 years ago, this video went viral, and it has been kind of a sensation on YouTube.
It's absolutely, that's the one. I'm sure you guys have seen it out there. It's a mirror, and the control comes from a rod to the center, and lifelike, but also wears a mask, so it's not trying to come off as human visually, but that performance that the figure does is so beautiful and so realistic. How long did that take to do?
Well, first of all, thank you. Yeah, I spent a lot of time on the nuance of the movements. The project was 5 months to build the actual physical girl herself, and then I spent another 4 months working on the software and choreography with Jordan. And then she had her debut in New York, and then I spent some amount of time really refining her vision system, because one of the cool things is she looks you in the eye the whole time while you're in the space.
It's tracking.
So this is face tracking, this visual face tracking, which is it's incredible when you're there in person. So I would say that this is the first time that I've spent a lot more time on the software than I have on the hardware.
Wow. And then you also worked on Robot Combat League, so you have some experience with the giant destructive robots too. Yeah. Is that something you want to go back to in the future?
Oh, absolutely. I have the humanoid robot bug now. That's really what I want to focus on, is humanoid robotics. Robot Combat League, for me, being able to do that was thanks to the experience I had in BattleBots, because there's nothing like BattleBots to teach you how to make stuff that can withstand incredible forces.
And be modular enough that you can repair and put on a good show, right?
Yeah, that's right. It's a real learning experience. We have a bunch of experienced builders here at BattleBots today. We also have some newcomers, and it's been interesting seeing who really came through with the designs and who still have a few things to learn.
And hopefully people out there will not only appreciate those robots, but also the robots on the side of the stage as well. Thank you so much, Mark, for chatting with me. We have to visit your shop. You got to bring us down there so we can check out more of your robots. We can get that sometime in the future.
I hope so, Norm. Thank you.
Awesome. And we'll have more stuff from this show from BattleBots on test.com. We'll see you next time. Bye.